Riddle me this, mother lekker.
Simplify and prove your answer to the following expression. You're not allowed to use calculators or computers. I received many email requests for this type of problem. Can you figure it out? Give this problem a try, and when you're ready keep watching the video for a solution. So how can we simplify this expression? I'll first write a as the number that's under the first cube root, and then b will be a square root conjugate that's under the second cube root. Notice that the cube root of a is a real number and the cube root of b is a real number, so their sum will also be a real number. So in the end we're looking for a real number. Now we'll set this entire expression, which is the cube root of a plus the cube root of b, we'll set that equal to x. Now we'll cube both sides and then we'll expand. Now let's simplify this expression. We'll first put the squares inside of these cube roots. Now we'll group these cube roots together. We can then write a squared as a and b squared as bb. Notice we have an ab term here and a ba term here, and they'll be equal to each other. What's the product of square root conjugates? The nice thing is it will be a difference of squares, and this simplifies to be -5 cubed. We'll substitute that in, and now -5 cubed, if we take the cube root of that we end up with -5. 3 times -5 is equal to -15. So we then have -15, and we can group the remaining terms, which will be the cube root of a plus the cube root of b. We now recall that x was defined to be exactly this quantity. So we can substitute that in. Now a plus b will be equal to just 16 because the square root terms will cancel. So we end up with a simple polynomial expression: x cubed is equal to 16 minus 15x. If there's a solution in this equation, or looking for a real value to be the answer to our original expression. So we write x cubed plus 15x minus 16 is equal to 0. How can we solve this equation? Well, usually you can try special values and you'll quickly see that x is equal to 1 as a solution to this equation. Consequently x minus 1 will be a factor of this polynomial. So we can factor this into the following product of x minus 1 and the quadratic x squared plus x plus 16. We can solve the quadratic using the quadratic formula, but we'll learn that the quadratic roots both involve non-zero imaginary parts, so there are extraneous roots. They can't be the answer to our original problem, because we're looking for a real value of x. This means the answer is x is equal to 1. Wow, this is a most unexpected answer for a simple algebra problem. Now you might double-check this exercise by typing it in Wolfram Alpha. Will it give the answer of 1? You might surprisingly find that it gives a complex answer with a non-zero imaginary part. What's going on? Well, Wolfram Alpha is using the principal root. The reason is the equation x cubed equals c has 3 solutions, and Wolfram Alpha will take the principal branch cut, which is most commonly used in higher mathematics. But we don't want the principal branch cut, we want the real valued root. So how can we force Wolfram Alpha to do that? There are a couple of ways. One is you can use the command of cube root that in fact will give you the real valued root and you will get the answer 1, and for other roots you can use the command absurd of x, and this will give you the real nth root of x. It's a pretty neat problem. Did you figure it out?
Riddle me this, mother lekker.